Hello everybody. Today we're going to talk about how to design a microprocessor. So last time we talked about how an ALU is built. Okay, arithmetic and logic unit is built. I showed you in the previous video how was an arithmetic and logic unit. Let's go out and check in what is the arithmetic and logic unit. Okay, so I was telling you about, so I'm just loading the things and just finding out what is the arithmetic and logic unit. So the arithmetic and logic unit has what is called a control bus, and you have an opcode bus, then you have a status bus, then you have what is called an input A operand and input B operand, and the output of the combinations of A and B. Okay, that is the kind of thing. So I told you already the control is usually used for controlling the operands, what kind of operation you want to do. Opcode is the one which shows you what is the kind of operation you want to do. Okay, so once you give the operand the kind of bits like 0, 1 or 2, and then say that okay, do this operation, the control bit, once it is 0, from 0 if it transfers to 1, then immediately that particular operation is like an AND operation or operation, and the status bit gives out what is the thing which is coming out, whether it was successful, whether the operation was successful or not. So once the status bit comes out as 1, then you know that that particular operation has been done. And what are the results? The results are put in out bus. Okay, out bus, and the things come out of the out bus. So the two operands A and B or needs what is called a register. Okay, an arithmetic and logic unit usually comes out from the bus and straight away goes out of the bus. Okay, that is the kind of thing which is an arithmetic, but you have to store the information somewhere. So where do you store all the information? That is called a memory unit. Okay, so today, last time we saw how an arithmetic and logic is performed, and using a bus and set of logical units. Okay, then now our arithmetic units, another thing, logical units can be even arithmetic units, and now we want to do what is called a transfer the whole thing into memory units. Okay, so basically a microprocessor, what is called, you have to know what are the basic contents of a microprocessor. A microprocessor usually have what are called registers. Okay, they have what is called primary registers or calculating registers. Then after that they have what is called a flash registers. Then they have what is called a first calculating registers, then flash registers, then they have memory unit, main memory unit. Okay, so it is an 8-bit bus or 16-bit bus, those kind of things. Okay, so that is they have, whole thing is done by using a flip-flop. So what actually the concept of a processor is, you have to do some arithmetic calculation, logical calculation, then you have to store it in some kind of memory, and then finally from the memory it is transferred on to the registers, calculations is done, then after that it's transferred from the ALU on to that particular kind of memory unit, whether it is a data unit, address unit or anything, and it is transferred on to that. So there are a set of registers which are called data registers. Then you have calculating registers. Then you have different kinds of registers. Okay, each register is made to do some kind of specific work. So these kind of registers, they operate in parallel or sometimes synchronous kind of thing operation. Sometimes they are out of synchronous depending on what kind of memory they are accessing and other things. Okay, so registers, if you can go and look up what are the different kinds of registers sometime later, but right now I don't know what is the kind of registers they use. Data register, then you have other kinds of registers. Okay, now we go out and find out what is the kind of, how a register is made. Okay, so registers are somewhat like this. Okay, registers are somewhat like this. Okay, let's see what is the register contain. Okay, a 8-bit register has SR flip-flops. Okay, SR flip-flops. Okay, not latch. Okay, latch means memory unit. Registers usually always have flip-flops. That is the first thing you have to know. Flip-flops are things which are doing the calculations very fast. So registers usually have flip-flops. Okay, So that is the first thing you have to know. So you have SR flip-flops as the one. So that is a set reset flip-flop. Okay, set reset flip-flop which sets all the uh, what are the what are how to do the calculation, set or reset and things like that. Okay, toggle is a kind of T flip-flop is a kind of toggle. It is mostly for control signals. Okay, toggle is for control. So control what you are going to do, what kind of things you are going to do, control operation, opcode operation, things like that. D registers are actually storing for permanent kind of storing where the things are very stable and kind of things. Okay, the D registers are like that. D flip-flops are the kinds which are kind of store all the information. Okay, now what happens when you give a toggle immediately from the D flip-flops, it is moved on to JK flip-flop. Okay, so when you have a set reset, then it is permanently stored in the registers. Okay, so set registers are the permanent storage of registers. Then JK flip-flop is the actual calculating kind of registers, and D flip-flop is the intermediary kind of register elements. And finally, you have the toggle, which is the control element. Okay, so toggle is a control element. Data D latches are the intermediate element of registers. JK latch is the kind of what kind of from the intermediary latches, it goes on to the JK latch. From the JK latch, it goes on to SR latch, and finally it is held on to the SR latch. So calculations are done usually on the JK latch. That is where the final processing happens. Okay, the JK latch actually does all the processing, and D latch and T latch and SR latch are all supportive elements of a register. Okay, this is the basic content of a register. So this is an 8-bit register which you can see right here. Okay, a register has 4 elements. You have to know SR, JK, D and T. Okay, T is for control, D is for intermediary storage, JK is for calculating, and SR is for permanent storage or for final elements of the register. Okay, the calculated elements of the register. From the registers, if you want to transfer to some other element, then you go what is called a memory unit. So there's a set of registers like register 1 8-bit, register 2 8-bit. So these are all similar things. Okay, now we are going into memory unit. Memory unit has got 2 things. One is the flash 8-bit and MMU 8-bit. Okay, so flash 8-bit has what is called an intermediate kind of storage unit. Okay, but these are all flip-flops within them to do certain specific operations on the particular register or memory unit. So SR, the main memory is an 8-bit kind of processor. So first thing is it has got a SR latch. SR latch is the main storage unit. Okay, from main storage unit, you transfer using a toggle, you get it onto a D latch. Okay, D latch is a temporary kind of storage. Okay, temporary kind of storage within the memory unit. Then after that, from the memory unit D latch, you get into a SR latch. Okay, not SR latch. Yes, SR latch. Okay, SR latch, from the D unit you get it to SR latch. From the SR latch you get it onto a JK latch. JK latch is where the actual memory is transferred from the memory onto the register. So JK is connected to the registers using toggle. Toggle is the control signals. Okay, and SR is connected to the JK for an intermediate storage of kind of flip-flop and transfer from the main memory onto this thing. And MMU is an 8-bit which has SR latch, which is the main storage. Then after the D latch, which is the intermediate storage. Then using toggle, it's moved on to SR latch, which is another intermediate storage kind of thing, which are mostly for clocking purposes, and it does the calculation very fast. And from SR, it is moved on to JK, where it is actually from JK latch, it is moved on to the registers. Okay, so from main memory to flash memory to main registers. Okay, this is the kind of order, but they are grouped into different kinds of units, and all are, if you take the main memory unit, it's going to be SR latch. Okay, Main memory unit will be R, SR latch and D latch and things like that, okay? And toggle is for the controlling the things. So a set of SR latch, D latch, toggle latch, SR flip flop, SR latch, uh, SR gated, okay, SR gated, and then finally SR latch, okay, JK latch. So first is SR latch, then that is the main memory kind of unit, then D latch, which is the secondary kind of unit, then it's using toggles are just for switching the things from one unit to another unit, basic kind of the clocking signals and other things. So from the toggle it goes on to SR gated. So SR gated is the first thing where the memory is kind of soft memory kind of thing. So SR gated is where the soft memory is there, and from SR gated onto JK latch. From the JK latch, once you get a toggle or a control signal, then it goes on to the register. Then this gets loaded onto the register. So from the JK latch only you can load it onto a register. Okay, that is the first thing. From SR register only you can transfer it on the next clock signal into JK register, and toggle are basically for the control unit which switching elements which do the toggling of the things, clearing and other things, okay? So you can do a clearing of the memory unit and other things using SR latches, okay? And if you want to intermediately clear, you can use it using SR gated, okay, intermediately clear. So once it is done, so the memory units, MMU and flash, and then after that it transferred onto registers. From the register calculation is done. From the calculation then the output is taken in a similar fashion and then reversed back and stored into memory. So how it is reversed back from the register, it comes on to flash, and from flash it comes on to main memory. So from the main memory it goes on to flash, from the flash it goes on to register. From the register calculation is done, then after that from the register it transfers onto flash, and from flash it comes onto main memory. So just going up and down is a kind of reverse process. So if we take an 8-bit MMU, this is what somewhat it looks like, but I have not given the connection for you to understand how the connections are made and things like that. Why I haven't given the connection is because it's quite complex. An 8-bit register is, and if you want to do all the connections of a main memory unit and a flash 8-bit and things like that, and how describe a complete register, what are the opcodes and things like that, it's going to be quite complex. Because right now I didn't make any connections, okay? Connections is a totally different chapter, how the connections are made and things like that. So it is a preliminary view of how it looks like, okay? So basic microprocessor has these elements, okay? Register elements, then intermediate kind of flash elements, then you have main memory elements, okay? These registers are grouped into different categories. I don't remember what are the kind of different categories the registers are grouped. I think it is A register, B register, and sometimes it is called address register, then data registers, then you have address register, data registers. Data registers basically for operands, okay? Address registers basically for loading and unloading. Those are the control signal kind of thing. So control address is given, and for loading. For loading and unloading, you do what is called a right shift, left shift, and you get the particular address and then load it, okay? So the processor is going to do these basic things. And so to understand a processor, first you have to know what are the basic elements. From the basic elements, you group the basic elements into what are the required units of the processor, and from the required units of the processor you do what is called a processing. So basically processor has a processing unit for memory and processing unit for data. So that is all for today. So you have a basic idea of what is a processor contain. So processor means arithmetic logic unit, a calculating unit, a address bus, a data bus, then finally a control unit. That's all. So control unit, address bus, data bus, then you have registers for data registers, address registers, and then you have a calculating registers or register 1 or doing all the kinds of. These are the basic units of a microprocessor, okay? So once you have these things, then you have made a microprocessor, but it is quite complex to do all the connection work. Okay, how we go to do all the connection, connecting all these kind of registers and kind of memory units and other things. It's quite complex. So the basic idea is the framework kind of thing. So the basic things are like this. Later we'll see how connections are made and how they switch and things like that. It's quite complex. So I don't have a kind of what are the basic elements. Let's go out and check in what are the basic elements out there. Okay, so I just go out, I try Google. So let's find out what is the kind of, like I say it is microprocessor. Okay, so now I search for it, then I have basic design of a microprocessor, and there what are the elements I want to see. Okay, uh, so I have the basic idea of operate. What are the so this doesn't give. Okay, I go into microprocessor chip. This doesn't have all this microprocessor chip and other things. Okay, let's find out what are the board design. So I just wanted to see a microprocessor 8085. Okay, this is the kind of unit. Okay, so this is the main kind of thing. Okay, now I wanted to show you. Okay, I already told you what are the kind of things. Okay, it's going to have registers and things like that. So the registers are made like this. Or there are something called temporary registers. Then you have A, B, C, D, E, H, L registers. Okay. Then you have what is called a stack register. Then you have what is called a program counter register. So program counter is also kind of register. Then you have what is called a increment or decrement address latch. Okay, address latch is there. What is the kind of address latch you do? And then you have a multiplexer to do all the things, and you have a register select. You can do a register select also, what kind of register you want to select. So then you have an address buffer, then you have a data address buffer, then those elements are connected to what is called an decoder and machine cycle, and what is instruction register. What is the kind of instruction? That is called the opcode. I told you already something about the opcode, or the status. That is a kind of instruction registers. And then you have the flags are kind of like whether something is done or not. Those kind of those are the flag flip-flops. And ALU already told you how the ALU is, like what is the kind of what is there inside an ALU. Temporary registers are used for transferring elements from. Accumulator is where you have the count. Okay, count of what kind of thing and what kind of things has been done. Accumulator is basically for calculation, like 1 plus 1 equal to 2, 2 plus 1 equal to 3. So clock and timing control. So clocks and other things are given like this. So this is how basically it looks like, but it is quite complex. So I just wanted to show what are the elements. So address memory elements, then you have register elements. I showed you what is the registers, all the registers, how it is made, how the memory, all the thing is made. Address buffer. Okay, address buffer is also a kind of memory unit. That is also kind of like how they are using latches to do all the things. The bus and all collection, how it is done, it is quite complex. I don't want to show it right now, but basic contents, what are the things. Okay, that is the kind of thing I wanted to show you. So let's read all the things. This is for image control. Okay, interrupt control. So there are other things also. So interrupts also there. Interrupts, if there is any problem or something like that. So they have interrupt control. Interrupt means the processor will be running, so you have to interrupt the processor to do some kind of work. Okay, so first is the interrupt control comes in. Once the interrupt control comes in, then after that the registers are there. Then you have an accumulator. Accumulator is where you have to addition, multiplication, subtraction, division. Then you have temporary registers which store the information on what kind of calculations have been. Then it is given to the arithmetic and logic unit. Then it is given to the flip-flops. Okay, flip-flops for doing all the flags or what are the status and other things. So those are the flip-flops. Then after that you have the timing and control. Clocking and other things I haven't covered. Clocking and control those kind of things are done by the timing and control chip, okay, controller chip, okay. Now the instruction decoder and machine checking encoding. So mostly the timing and control has a complex circuitry kind of thing, okay. It doesn't have some of the basic logic circuitry is there, timing and control, okay. They basically do the all the timing controls of the things, okay. Now instruction registers is where I told you how to construct a register and everything. So instruction register is the fast register, how to load an instruction, what kind of instruction you want to do, whether you want to do an addition, subtraction, or you want to try to do a transfer from one register to another register, or you want to store the thing from one register to an address buffer and things like that. So those are called the instruction registers. Decode, so you have the coding and decoding for the instructions, okay. Instructions can be coded and decoded. So what is move instructions and add instructions, subtract instructions, those kind of things are there, okay. Now this is the multiplexer which does all the things, okay. Multiplexer which has a kind of like moving from registers to registers. This is a kind of multiplexer which has all the, so address buffer and data buffer is given here. So address memory, this is the address memory. Address buffer means address memory. Data buffer means data memory. Memory basically it's a buffer kind of unit. From there it is transferred to the buffer is also a kind of latches, okay. So address buffer is a latch, data buffer is a set of latches, okay. How you do all the things, and this is the multiplexer which has the main kind of registers, okay. Register calculation I told you how to do. Then memory unit I told you all the latches. So address buffer, data buffer has all the latch works, and multiplexer is a kind of timing circuitry which is control signals and other things, okay. Now timing and control is given by this, and that's all the basic microprocessor contains, okay. So if you want, you can go further and do all the register work and design work and other things. So how these individual chips are made is basically how they are connected. Once you have a registers and memory units connected, and how data is transferred from the memory to the registers, does the calculations, whether it is the control signals are the one which does all the kind of controlling the whole processor. That's all for today. So how we do a data transfer also is there. So that is all for today. This is enough for today. So I have the basic idea of how to construct a processor, okay. I showed you the basic things of what the processor contains, and what are the elements, basic elements, what are the overall structure of a processor has, and how to construct all the things, and the connections and other things is quite complex, which you don't want to deal right now. And each one has a kind of chip made for those connections kind of thing. That is done by multiplexers and other units which are there for quite complex circuitry, okay. That's all for today. So let's see some other time. So we go back. And the register main processing unit. See, so this is the kind of registers. I would address register, data register, calculator, multiplexers, and those kind of things. So I just wanted to show how the arrays are formed. Like if you want to go look up at it, so SR, JK, D latch, T latch. T is for timing and control, D is for data, intermediate data, SR for JK is for JK latch is for intermediate kind of storage, SR is for final storage. So JK is JK flip flop is where the calculations are done. Okay, that's all for today. Thanks. Bye now.